So we mentioned the different types of charts. Here we're looking at the X bar. And so page 49 gives us what we're supposed to be using for that. We have X double bar and R bar. So X is the individual observation and is the sample size of a group. K refers to the number of groups. R is an individual range. And then, Ri is the individual range, and R is just the difference between the largest and the smallest observation in a particular sample size. All right, so we're going to look at how we construct that. So we need this ratio between the average range and the standard deviation. And there's some tables that could help us with getting some of these constants that we see here, like A2. D2 is that ratio that I mentioned, and that's R bar divided by sigma. And we have what we're going to be using to establish the upper and lower control limits while looking at that center line. So pages 49 and 50 help us out with this. But we're going to have an example of the X bar as well as R chart in a little bit. The R chart is constructed in the same way, very similar to the X bar. We could establish the upper and lower control limits. The center line is going to be the average range. Then we have these constant D4 and D3, which again we get from tables. So page 51 gives us the information that we need for X bar and R charts as it pertains to the various constants. Here's the D2, D4, D3, and A2. And based on the group size, it tells us what we're going to be using for each one of those constants. So we have an example. We're going to be able to apply both charts. So assume that control charts are to be established to monitor the weight in ounces of a propellant that is loaded into various canisters. The canister is supposed to hold 10 ounces of the propellant. And in order to achieve the 10 ounces, the process must be set to deliver slightly more. So we have samples of 5 that were taken every 30 minutes. So sample number 1, here's the various sample values: 11.3 ounces, 10.5, 12.4, so on and so forth. And the table is nice enough to give us the mean of those samples as well as the range. Range, again, this is the high, and then the smallest one is what, 10.5, so we get this. Now, as it stated, we have 20 samples, and again, within each sample, 5 measurements were taken, and we have all the data there. So, the average of the ranges is calculated to be 2.05, and we do that because we have the ranges here, and we add them up and just divide by 20. So we get 2.05. Now, in order for us to establish the upper and lower control limits, we have to use this here, right? D4 and D3. So since we have, here we go, we have our constants here, 2.115 and 0 for our D4 and D3. Multiplied by the average range, which is 2.05, we get 4.34 as our upper and 0 as our lower, because the constant is actually 0 for D3. So this is what we use to see, if we are within range with our particular process. And obviously, we want to use those out of control signals to understand where we're at and if anything needs to be done.